Hey everyone, and welcome back to the channel. Before we dive into today's main topic, I want to quickly address something from our last video, which is how to set up your project and manage dependencies in Semantic kernel. The easiest way to get started is by using Nugget, the package manager for .NET. To add the Semantic kernel package to your project, use this tab in Rider. In Visual Studio, it's quite similar. Just right-click on the project where you want to add the package, and you will see a context menu that lets you add Nugget packages of your choice to the project. So if you, for example, type in a package of your interest, for example, Mapperly, here on the right side, you can add that particular specific package to the project, the previously selected project, and that's all. Now with our project properly set up, let's dive into the main topic. Today, we are diving into one of the most powerful concepts in AI development, function calling. Simply put, function calling is the ability to reliably connect a model to external tools and APIs, thereby overcoming their inheritance limitations. Think of it this way. LLMs are powerful, but they have three major walls they can't break through on their own. First, there is the knowledge wall. An LLM's knowledge is limited to the data it was trained on. It can't access real-time information like the current weather or a stock price. Function calling allows us to bridge this gap, giving the AI access to live data and private documents. Next, we have the execution wall. An LLM cannot directly perform actions. It can't send an email or process a payment. By calling external functions, we give the AI the ability to trigger concrete actions in the real world. And finally, the ability wall. While LLMs are good at general tasks, they may be less efficient for specialized calculations or complex processing. With function calling, we can delegate these tasks to external tools like a complex math library. In semantic kernel, we call these external tools plugins. A plugin is a group of functions, typically C# methods, that are exposed to our AI application. This slide explains how function calling works in semantic kernel through plugins, which are groups of functions exposed to AI applications. Each function is defined in a class and annotated with kernel function attribute in C#, along with a description to guide the AI in choosing the right tool. Clear and accurate descriptions improve the AI's grounding and reliability. Example plugins include math tools, time, jokes, weather, businesses, and here this is a typical C# example showing how to implement a simple timing plugin. Here in our code, you can see two simple plugins. This is the weather plugin, which has a getWeatherAsync method, and to tell the AI that this is a function it can call, we use the kernel function attribute. We also use the description attribute to give the AI a clear, human-readable description of what the function does, which helps the model decide when to use it. Similarly, we have the currency plugin, which contains functions like convert currency async, get exchange rate async. These methods are also decorated with the kernel function and have detailed descriptions. You can see that this plugin has a fallback mechanism for when the real-time API fails, which is a great practice. Let's run the first example to understand how it works. First of all, we verify the first line is uncommented, and here is where we have our first demo. A crucial configuration for this setting is the tool call behavior to auto-invoke kernel functions. This explicitly tells the kernel to let the AI automatically choose and execute the best function for the job. This is also known as function advertising. And let's pay attention to this line. Here is where we are importing the plugin we were talking about into the kernel. So let's run it. Okay, it's starting up. Okay, enter your message. For example, how the weather looks like today in Madrid. Okay, and in Malaga. And now we are going to set up a breakpoint here. Okay, now we are demonstrating effectively the plugin is being called. So that's it for the first demo. Okay, but how automatic function calling works? The process is a loop that repeats until the model returns a final chat message. First, Semantic kernel serializes all the available functions into a JSON schema, which is sent to the LLM. The LLM processes this input, and if a function call is needed, it returns the function name and its required parameters. Semantic kernel then invokes that function on your behalf, and the result is sent back to the model as part of the chat history, giving the AI the information it needs to continue the conversation. As we mentioned before, a crucial configuration for this setting is the tool call behavior set to auto-invoke kernel functions, which explicitly tells the kernel to let the AI automatically choose and execute the best function for the job. Okay, now let's take a look over the second demo I have previously prepared, which is the parallelism demo comparison. This demo will show the power of parallel function calls, a feature in some of the LLMs that allows them to call multiple functions at once to save time. So before execute the demo, let's switch to our program CS file and make sure that it is uncommented. Okay, let's run it. Here, notice how the sequential function calls demo takes time to complete each task one by one. It has to wait for one currency conversion to finish before starting the next. Okay, we hit this breakpoint. F5 to continue. And now look at the parallel function calls demo. We are asking for all 5 operations in a single prompt. The AI intelligently recognizes that these tasks are independent and can be executed at the same time. This is a huge efficient gain, as you can see from the execution time. Okay, to understand better the results of a demo, we are going to take a look over the code. For the first method, the sequential functions called demo, what we see is several queries, several prompts that are invoked independently, one by one in a row, and finally writing down the total duration. Whilst for the second method, the parallel functions called method, what we see in this case is just only one prompt, the parallel query string, and the kernel is invoked just only one. So the kernel decides itself how to invoke those functions in parallel. All right, now we are going to take a look over the source code of this third demo, which is currency conversion demo, in order to understand better the currency plugin. And the code is pretty straightforward. As always, creating the kernel, importing the plugin, and creating the settings. With the settings now we are going to create the arguments, and finally to invoke the kernel, we will do it by passing this prompt plus the arguments. Very straightforward. So if we take a look over the source code of the plugin itself, we see it contains several methods, okay? And notice, pay attention that for some of them, the name is grayed out. And this is because we are not making a reference or a call within our source code. We demonstrate, which is the kernel itself, that will invoke automatically these functions as appropriate, okay? So here we have the convert currency async, this one, and this one. And this is a helper method, which is private. Basically, we are getting access to this URL. Okay, if we set a breakpoint for each of the methods, we will see where the kernel uh, invoke which function yes and which function will not be invoked at all, depending on its circumstances. So if we run the demo, it is starting up. Okay, this first function has been invoked, has been called. F5, this other function has been also been called. And the demo has been completed. However, the kernel decided that a call to this specific method wasn't useful, was not necessary at all. Finally, let's talk about security. Giving a model access to external tools can introduce risks, but we can mitigate them. We will focus on three main risks: excessive delegation, which is giving the model too much power, for example, an unrestricted API call that could delete a user from a database. Another topic could be confidential information leakage. Sensitive data, like API keys, could be accidentally exposed in the context window. And finally, the server-side request forgery, where an attacker tricks the model into accessing internal network resources. But in semantic kernel, we can mitigate these risks using the I function invocation filter. This is a powerful feature that lets us inspect and validate every function call before it is executed. Look at our security filter class. We can use this filter to add business logic and security policies. For example, our filter blocks cryptocurrency conversions and restricts weather lookups for certain cities. Now let's go back to our program.cs file and let's execute this demo. Okay, it can take a few seconds. So as you can see, the filter successfully allows the approved operations, but then it detects the block cryptocurrency conversion and the restricted city for the weather request and stops the entire operation before even reach the plugin. So this shows how we can prevent excessive delegation and server-side request forgery by carefully validating inputs. All right, taking a look over the code of the demo, pretty much the same. Creating the kernel, importing a couple of plugins, and now we are adding our security filter class to the function invocation filters list. And after that, the rest of the code should be pretty familiar for you. And finally, we are doing step by step, all in a row, different operations. Some of them could be blocked, some of them could be rejected or allowed. And that's it. Okay, now we are approaching to the end of this video. For the last demo, honestly, nothing new. So this is something that we saw before. The only point is now we are letting the kernel to decide automatically when to call the function, because we do have only one prompt and we are passing the arguments in the same way that we saw before. So if we run this demo, you will realize that it is pretty much the same, but good to exercise for a second time the same concept. Okay, it's processing, and now the final result, and all the requests have been processed. The following request couldn't be processed. Okay, this is block, this one is also block, and that's it. Okay, before wrapping up, let me share with you some considerations. To improve function schemas, consider a few key points. To start, keep schemas simple and concise to reduce token usage and improve response time and cost. Next, use specific parameter types like enums for sets of choices and numerical types like int or float for precise values. This helps models generate more accurate responses. Also mark parameters as required only when necessary to enable the model to call functions faster and reduce validation errors. And finally, use clear and unique names for plugins and functions. While function descriptions are optional, they can be a valuable tool to guide the model, especially when it struggles to understand a function's purpose. All right, we have reached the end of this video. I really hope you have found this video interesting for you. Thanks for watching and see you in the next video.